Welcome to video 2 of the We Are Ready date or solutions. Notice that this particular set of solutions is a no calculator set. Okay? You are not allowed to use a calculator on this. Now let's talk about that real quick though. Okay? Keep in mind that on the ISTEP you are not allowed to use a normal calculator. You have to use the calculator that is built in to the ISTEP. So if you're wondering how you can see that calculator and practice using it, if you go to the school website, under Students, Links and Testing, we'll bring up this list of links. Now if you look, there are several options here that look like they could be the right thing. What you want to do is go to the Practice ISTEP link, and if you click on that link, it will take you to this page, which is the ISTEP online experience for the various grade levels. You are a grade 10 student, so you would click on grade 10 online experience, and it would log you into the online experience practice test, which is 4 questions long. Now, what you're going to do on here is you could practice graphing, things like that in here, but mainly what you've got is, here is the calculator emulator that you are allowed to use on the ISTEP. It is a TI-84 Plus. So on the sections where you're using the calculator, I would highly suggest that you are practicing using this emulator. Okay? Because this is the calculator that you get to use on the ISTEP. All right, back to business here. Again, this is a no calculator section. So in the videos, I will use that emulator when I need to use a calculator. Okay, so the area of a square is 75 square feet. Which answer demonstrates the correct length of the square? Well, if we go to the reference sheet, which again will be available to you as a link online, you'll notice that nowhere on the reference sheet does it tell you the area of a square. That's because you're expected to know that information. Okay? The area of a square, basically a square is a rectangle. So the area of a square is length times width. But in a square, the length and the width are the same. They're both known as the side length. So you should realize that the area of a square is the side length squared. Now if we draw a picture, which is an excellent idea by the way, here we have a square. We do not know the side length of the square. So what do we do when we don't know something? We use a variable. So we have a square that is x feet by x feet. And we don't know what x is. But we know that the area is 75 feet squared. So what we do is we set up an equation. Area, 75, equals s squared. Now we've been solving quadratics for most of the year. Everybody should recognize this as being a square root problem. We need to take the square root of each side. Now this is a no calculator portion, so you have to know how to reduce that root without your calculator. That is not a hard root to reduce. 75 does not have a perfect square root. But 75 is divisible by 25. It's 25 times 3. So we are going to break that square root into a square root of 25 and a square root of 3. The square root of 25 is either positive or negative 5. And square root of 3 does not reduce. So x is plus or minus, because technically I took the square root here as well, which was x. However, this is a length problem. Length, side length, must be positive, which means x is 5 root 3, and our units are feet. So the side length would be 5 root 3 feet, or c. Okay, on to the next problem. Here we have, this is a number theory problem, seeing whether or not you truly understand what a rational and an irrational number is. So you should know that rational numbers are any number which can be written as a fraction. Okay, essentially, in your head, you should hear the word fraction whenever you read the word rational. Now, I know you're not fond of fractions, but let's keep in mind that every decimal that ends or repeats, whether it ends or repeats, can be written as a fraction. So any decimal that ends or repeats is rational. All fractions are rational. All whole numbers, positive and negative, all integers are rational. Okay? And then we have our irrational numbers. Now, irrational, in terms of this test, are going to be pi and any square root that does not reduce. So just off the top of my head, here are a few. Now keep in mind that those could have numbers in front of them too, or they could be inside a fraction, in which case that would be irrational as well. Okay? So if we look at x and y, x is irrational, and y is rational. So it says, which statement best describes the product? Now you're supposed to know that product means multiply. So they're asking you about x times y. Well, that would be root 7 times 8, which would be 8 root 7. Well, ladies and gentlemen, I just said up here, if you have a number times a root, that's an irrational number. In fact, you can put it this way. The product of two rationals is always rational. The product of one rational number and one irrational number is always irrational. And finally, the product of two irrational numbers that's the hard one, because it depends. Sometimes it's rational, sometimes it's irrational. But in this case, one is irrational, one is rational. In this case, x is irrational and y is rational. The product, therefore, must be irrational, because when I multiply a rational times an irrational, I always get an irrational number. So as soon as I know the answer is irrational, I can use my answer eliminator to eliminate A and D, and then I just have to correctly identify which of my variables, x or y, is rational. In this case, y is rational, and that gives me the correct answer to that question. The next question is very similar, but it says sum instead of product. So let's give the computer a minute here to change the page. All right. So here we have r is 1/3 and s is 2.9. Those are both rational numbers. Okay, this is another number theory question, but now we're talking about sum. So it's asking for r plus s. Sum is different. Okay? The sum of two rational numbers is always rational. If you can add two fractions, you will always get a fraction. Always. However, the sum of two irrational numbers is always irrational. Always. And the sum of one of each is always irrational. So, in a way, sum is actually easier than product. In this case, if we think about this, both R and S can be written as fractions. R is 1/3. S, written as a fraction, would be 29 over 10. To add those together, we have to get a common denominator. So we'd multiply the first fraction, bottom and top, by 10, second by 3, so that they both become over 30. That would be 10 over 30 plus 57 over 30, which would be 67 over 30. Note that is a fraction. By definition, all fractions are rational. So right away, as soon as we know that the sum is rational, our answer eliminator tool can be used to eliminate answers A and C. And then if we look at what the rest of that problem says, B is the only one that makes sense because it's the one that says that both R and S are rational numbers, which we said at the beginning they were. That's a pretty standard number theory question for the ISTEP. So you need to be able to recognize rational numbers and irrational numbers, and you need to know the facts that I have put on these last two slides. You need to know that when I multiply two rational numbers, I always get a rational number. That when I multiply a rational and an irrational, I always get an irrational. When I add two rationals, I always get a rational. When I add two irrationals, I always get an irrational. Those facts. Okay? Finally, I think there's one more. Maybe not. Oh, there is one more. Okay. We have these two tables for f of x and g of x. Now remember, f of x is a fancy way of saying y. Okay, so in both cases you've got a domain and a range, an independent and a dependent variable. So it says which function is linear? Well, what makes a function linear? A function is linear if it has a constant rate of change. Okay, if y, change in y over change in x is constant. Change in y over change in x is constant. That's what we look for. We look to see if both columns, both rows in this case, are changing by the same amount. So to go from 5 to 6 is a change in x of positive 1. To go from 6 to 7 is a change in x of positive 1. See what I'm saying? To go from 7 to 8 is a change in x of positive 1. To go from 10 to 12 is a change in y of positive 2. 12 to 14 is a change in y of positive 2. It's a change in y of positive 2. So number 4 here, or f of x, has a slope of 2 over 1, or 2, which is constant. So f of x is linear, period. So if you look at your answers, the answer is C. It has to be C. Okay, now I will say the reasoning is not great. Okay, the reasoning is not great because the x values in that table are not being multiplied by 2. That's not what it's saying. It's saying if I take the x value and I multiply it by 2, I get f of x. What it's saying is f of x is 2x. That's the equation, f of x. They're right. That's a linear equation. It doesn't have an intercept, but it has a slope of 2, a constant slope. Okay, if you look at g of x, the first 2 times the change in y is 6. But the third time the change in y is not 6, it is what, 14? But the change in x is always plus 2. So even though the change in x is constant, the change in y is not constant. So g of x is not linear because it does not have a constant rate of change. So the answer there should be C. Again, if you're trying to tell if a table is a linear function, there's several ways you can do that, but the easiest way is to just find the slope. See what the differences are between each row of the table. See if it is consistent, if change in y over change in x is always equal to the same number. All right, that should do it for the second video. I hope very much that you're finding these useful and that you're going to continue to work these worksheets and watch these videos.